Okay, so today's question is find the largest area of the square inside two rectangles. So there exists a rectangle in 2D plane with edges parallel to the x-axis and the y-axis. You are given the two integers array bottom left and the top right. We have given this array bottom left and the two right. Suppose there is a rectangle whose bottom left is 1 1 like this and top right is 3 3 this. So this will form a rectangle. Similarly 2 comma 2 and 4 comma 4 will make 2 comma 2 and 4 comma 4 will make a rectangle, and similarly all the indices together will make the rectangle. So we have to find a square in the intersection area of any two rectangles, and we have to provide the maximum area of the square we can get. So first let's try to calculate what the length of the rectangles we have given. So n is equal to length of bottom left, and initially we can keep max area is equal to 0. Now we should go through each pair. Okay, each pair, is there any common squares between them, each pairs of the rectangle? So for that let's go create a loop for I in range n, for j in range I plus 1 to n. Okay, so we will calculate four things: left, right, top and bottom. So if there is an intersection between these two squares, suppose, so from where the common indices will start, of course the maximum of this 1 and 2, and from where the right one will start, the minimum of this 3 and the 4. Okay, so that's how we will calculate left, right and top, bottom. So let's calculate left is equal to max of, we will take the common part, that's why for the left we are using max. So bottom left of I 0, this one 1 comma 1 from this for 1, and then for the other one bottom left of j of 0, this one. This is the another rectangle, so this is j, this we will compare this one and the 2, which is greater 2. So our common area start with the 2. Now we will go to the right. For the right we have to take the minimum, means which is still common in both. So minimum of top right of I of 0, which is top right, what is here, this 3. Okay, 3, and other one top right of j of 0. What is j of 0? C of 4. So what is minimum between 3 and 4? So 3. So this is the left is this, right is this. This is the common part. So we have got our left and right. Now go to bottom. For bottom again we will take the max part, as we are starting from it, so we want the maximum which is common currently. So bottom left of I of 1, this one. Bottom left of I, what is here, y-axis, this is 1. Okay, similarly we will go to bottom left of j of 1. What is bottom left of j of 1? This is 2. So which is 1, 2, which is maximum? 2 is maximum. So we will keep this height as the bottom one for the square, for the intersection square we are finding out. So what will the top? Top will be again the minimum of top right of I of 1. What is the top right here? 3. Okay, we are calculating the height of the intersection here. So 3, and again top right here also R should be capital, top right. Okay, so top right of j of 1. So what is top right here? This j of 1 for 3 and 4, which is minimum 3 and 4. So we get the height as this and this as the length. Now let's see if there is any intersecting area or not. So if left is less than right and bottom bottom is less than top. That means we have the intersecting area, so we can simply calculate width is equal to right minus left, height is equal to top minus bottom, and whatever will be the this minimum of width and the height, that will be our side of the square. So side is equal to minimum of w comma h, width comma height. Then we can simply update the max area is equal to max of max area comma what is the square of what is the square means area of a square, that will be side square. So and simply return max area. Let's try to run the test cases. Yeah, so test cases have been passed. Let's try to submit this. Yeah, so our code has passed successfully. Thank you.